Hey guys, and welcome to the channel. And if you want to know how I made this, then stick around. So for those of you who don't know, this is the Mystic skin for Genji in Overwatch, which is a game that apparently some people like. I get bullied by 10-year-olds every time I get on, but that's just me. This Cyberdemon Genji skin is so sick, and I was never able to get my hands on it, so I thought, why not make it? This was a super fun project just because of how much went into it. It has motorization, of course, which requires servos, programming in Arduino, connecting everything. It also has some lights in this green part because I'll show a clip of it right now. This helmet actually glows and like radiates mist. But as you can see, there's some lights in here that can turn on and off, and they flash if you want to take it to a rave or something. And this awesome file is by Walsh3D. He modeled the motorization into this mask. And honestly, it's a beautiful file. It looks really cool from every side. I love how this hair comes out. And last but not least, one of the things that I think is coolest about this helmet is this awesome looking resin printed skull. That's right, this is not FDM printed with plastic. This was resin printed from a place called PCBWay, who actually provided this for me to make this video. So yeah, you'll hear about them later in this video and how I got this awesome skull. So yeah, let's get into how I made it. I'm going to show you every step: printing, sanding, motorizing, and painting. So let's get into it. So first off, let's look at Walsh3D's file for this helmet. This is going to be on a site called Wireframe, where he and a bunch of other talented modelers make some really cool files. I'd highly recommend checking it out. So we've got some nice renders here where we can kind of see all the pieces we're going to be dealing with. So let's bag this and get to slicing. So this file only comes with one side of the faceplate, which is actually pretty normal. They do this because you can always use the mirror function in the slicer and just get the other side. My main goal with the faceplate is to retain the scaled texture. There is a non-textured option, but I just wanted to push it and see what kind of quality my printer could put out. There are a few steps you can take to get a cleaner, detailed print, one of which is to decrease the layer height. I did this at a 0.16mm layer height because my ender puts out really clean prints, but you may want to go lower if you don't know your printer that well. After that, I try to position the print as vertically as possible while also making sure that as few supports as possible are touching the textured surface. This was pretty tough to balance out, but eventually I got a result I was happy with. So the main dome of the helmet can either be pretty simple or pretty complicated to slice, and I ended up making it really complicated for myself. I have two really large printers, but I decided to print this whole helmet on my Ender 3v2. I made a video about upgrading it a while ago, and I wanted to get some good use out of it. So if you're slicing this for a CR10 or anything larger than that, you don't need to cut this at all. But if you're using something like an Ender, then you'll need to do what I did and cut this into 3 pieces. After that, they're just 3 simple prints. The magnetic backplate that attaches to the dome is super easy to slice on any printer. Just stand it upright and you're good to go. The hair looks pretty menacing, but it's actually pretty simple to slice. Really, the only way to do it is to position it vertically like this. The individual hair pieces won't need any supports, just the very front of the hair. If you're using a larger printer, you won't need to make any cuts, but since I'm using an Ender, I had to cut off some of the ends that exceeded the build height and just print them separately. The only problem with this is that there will be some pretty nasty support marks on the very front of the hair, so we'll just have to deal with that in post-processing. And there's also some little pieces for motorization that we need to print. You'll need to print 2 servo arms, 2 helper arms, and 2 servo holders, each of which are mirrored the same way we mirrored the faceplate. And with that, let's get started printing. So you may have been wondering why I didn't print what is pretty much the main piece of the helmet, the green skull. I could have FDM printed this and painted it green, but I really wanted that translucent, glowing look it has in the game. And something I think would lend to that effect a lot better is resin printing. The only problem is, I don't have a resin printer. and I wouldn't have a good place to put it even if I did get one. So does that mean I'm stuck if a project I want to make requires SLA printing? Not necessarily. PCBWay provided me with these beautiful resin prints for this project. I was able to use their 3D printing service to customize this print exactly how I needed it. They offer a wide variety of options so you can get exactly what you need for your project. All you need to do is drop in your STL file and customize it. For printing materials, they offer FDM, SLA, and even aluminum, stainless steel, and titanium printing. For my needs, I chose SLA and went with this transparent resin. They have a lot of different options for resin, including flexible, which is super interesting. And I was also able to choose a color for dyeing the parts, and they had a green that was exactly what I wanted. Although I did decide not to dye the eyes so they would have a good contrast from the rest of the skull. After that, the request will be processed, and you can wait to get your resin printed parts. I was really pleased with how these were packaged so they wouldn't get damaged during shipping. They all looked super nice and smooth. Not complaining about this cool looking ruler either. So here we go into our next step. What I'm doing now is plastic welding the 3 parts of the helmet together that I split up in the beginning. There's quite a few tutorials on YouTube if you don't know how, but it's pretty intuitive. All you really need is a soldering iron. My method is usually to line up the pieces the best that I can and then make a tiny weld just to hold it in place before continuing, in case I line any of them up incorrectly. Then just weld away. Just make sure to wear a respirator while doing this. They're not very expensive on Amazon. This is supposed to be fun, not a threat to your health. I also used the same method with the hair pieces that needed to be printed separately. And now we get started on everyone's favorite thing, post-processing. This is definitely my least favorite part of the process, but it's probably the most important for making a really good looking prop. So the first thing I did was a really rough sanding of most of the pieces with an electric sander. I first used 60 grit paper, then 150 grit, and then switched to hand sanding with 120 grit. The idea is to start rough to cut down the layer lines, then gradually progress to finer sandpaper to smooth out the surface. There are some spots that cause some trouble with these pieces, and those are the weld lines and the support marks on the front of the hair that I was talking about before. With these, I used a very generous amount of Bondo spot putty. I ended up doing this multiple times throughout the process to cover these gaps the best I could. So this was my process for most of the pieces, but I approached the faceplates a little differently. I really wanted the textured faceplate for this helmet, but that meant I couldn't sand it, and it might end up looking pretty bad. But I just kind of did it anyways, and it ended up looking pretty good. So I sanded all of the non-textured parts of the face normally with 120 grit sandpaper and just left the textured parts alone. And with that, everything was ready for priming. Just to get rid of the elephant in the room, yes, I know this looks like it belongs in a found footage horror film. I had to film this at night and I didn't realize how creepy it looked. So before I primed these parts, I ran a tack cloth over them to get rid of any dust that could be on the surface. I did wash the prints beforehand, but it's easy for dust to get on there pretty quickly. I used filler primer for most of the parts to really help fill in those layer lines, and regular primer on the faceplate so it wouldn't get in there and ruin the texture. Don't worry, when I paint these I'm going to have a way better setup. So for most of these parts, I'm going to sand down the filler primer, throw some more on, and give that a wet sanding. For the faceplate, all I'm going to do is give it a really high grit sanding and just call it a day. After that, we're ready for painting, right? Well, not quite. We actually have to make this thing work, and the first order of business is installing the magnets. When you buy this file, the README will tell you exactly what kind of magnets you need to get. The file is modeled to perfectly fit these magnets, but that doesn't mean your printer is going to print these out just right. If your printer has perfect tolerances, great. But for the rest of us, we're going to have to use a little bit of heat. My method for this was to touch each magnet hole with this lighter to get the plastic moldable, and then put the stack of magnets in to make it fit. After shaping the plastic, I used a little bit of super glue to stick those magnets in there for good. The next thing we have to do to make this thing work is motorization. The servos you want to get for this project are MG90S servos, but a very specific type. As you can see, the arms that stick out are placed a little lower on the left servo. This is the one you need to get. If you just look up MG90S servos, you will not find this specific type. You'll either need to look carefully at the pictures of each listing, or just use the link in the description to get the ones I bought. Next, you'll need to take one of the plastic servo horns and use the snippers that come with most 3D printers or any other cutting tool to cut them into this shape. It has to be able to fit into the servo arm that we printed earlier. It took me a few tries, but it doesn't have to be perfectly cut. It just has to fit in there. All I did was use a little super glue to stick it in there. I would try to get the servo horn to be as parallel as possible with the printed arm, because we don't want this being crooked. After that, you can use the little screws that also come with the servos to screw the servo into the bracket we printed. After that, we can take the servo arm we just made and attach it. Then we can go ahead and screw this into the faceplate with an M3 screw, and the motorized faceplate setup is complete. So now that we've got the servos all set up, the next step is to actually make them run. Here's a montage of the wiring, and I'll go ahead and explain what I did afterwards. All of this is explained in Frankly Build's video. I'll link it down below. He shows the whole process on how to get all of this together. Right now I'm just going to do a little overview of all of this, just so you can see what I'm doing. So here we have the central power of the whole helmet. This little USB battery pack you can get for like a few dollars at the dollar store. Even if it has like a crazy pattern on it or something, you're never going to see it. It's going to be hidden in the helmet, so it doesn't really matter. So we've got the main power here, and here's the cord that connects to that. This is actually going to come through this. This is called a Penelope board. It's made by Crashworks 3D. What happens is when you run one of these Arduinos off of one of these battery packs, sometimes as a safety mechanism, this battery pack will automatically turn off. And that means you'll be using this, and then suddenly you just will not be able to anymore. This Penelope board, I'm not sure exactly how, but it just makes it to where that doesn't happen anymore, and it's just a huge help. So all this is a plug from here to the Penelope, and then this is just a little decapitated USB cord. By the way, you have to get a certain kind of USB cord for this. It has to be a power cord and not a data cord. I learned that the wrong way, unfortunately. And the way you'll know it's a power cord is because it does not have this symbol on it, because that's the data symbol. So if it doesn't have that on it, you're good. And if it's a power cord, it should come out in a positive and negative cord. I haven't shrunk this heat shrink yet, so it's just going to be kind of out in the open here and secured there a little bit with hot glue, so that's why it looks like that. So the positive cord of this is going to run to 1, the Arduino, and 2, it's going to run to both of the servos, which are connected to this red and blue right here. So this positive cord is split 3 ways, 1, 2, 3. And the negative cord coming out of here, same thing. 1 goes to the Arduino, 2 more go to both of these servos, and there's actually a 3rd one that's going to go directly to this little switch right here. So there we have our power source. Now just the signals are left. So we have 3 signal wires coming out of this, one of which is right here, and this signal goes to the switch. So that way, when this switch is activated, when these 2 are connected, basically, it's going to tell the helmet to open or close. Then we have 2 more signals, 1 and 2 right here on pins 9 and 10, and these go to both of these servos respectively. All of this to say, this may seem a little daunting, but when you look at it and understand it, it's really not that bad. And I think any of you, by following Frankly Build's video or just by looking at this, you'll understand what you're doing. But this is the complete circuit that's going to go inside my helmet. So this was my first time testing the motorization. I just had one side done and I was holding the servo in place inside the helmet by hand, but it worked. Hey, so we're switching to live video now. Bet you can't tell what holiday it is. And this is where we're at with the helmet. I have the motorization finished now. These servo mounts are actually welded in here to the plastic, so they're not moving. But we do have a problem. There's actually a gap in between the two pieces. But I'm just gonna be honest, I've been troubleshooting this for a while. I reprinted this. I 3D printed screws that had the side kind of chopped off here, because ones that are all the way around like this, you'll see it creates kind of a weird angle as it goes in, and the top of the screw will collide with the part right here, and it actually causes it to stick out right here, and I think that's what was causing some of the gap at the beginning. All I did was I 3D printed an M3 screw, M3 times 10 I think it was, and I just like chopped off one half of it and it fit in there. And I also printed out some other variations of the helper arm. I tried to elongate it or thin it out a little bit in the slicer, and I still have this little gap. So honestly, I'm just accepting it. But the reason I'm okay with this gap is because the mask looks super cool opening and closing. So the plan is, this hair is going to be sitting on top of here, obviously. I'm going to hide all of this stuff just in the top of the hair right here. I made these servo cords super long so that they could stretch just anywhere they needed to in the helmet, but I'm pretty sure I'm just going to hide all this stuff in the top here. Alright, so we got a little time jump here, but this bad boy's all put together now and on his stand. All we have to do is press this switch. And there we go. So we do still have that gap in the faceplate, which I've decided is worth it, and I still want to motorize it. But to compensate for that, I had to push these magnets out a bit so they would still make contact with each other. So they do stick out a little bit, but it doesn't look too bad. And basically how I push these magnets out, it was a little trial and error, but basically there's just some hot glue stuck in these holes right here, and I just super glued the magnets on top of the hot glue. So the hot glue is basically just pushing them out a little bit, and the super glue is just keeping those magnets inside the helmet, if that makes sense. This may depend on your certain helmet, because I'm sure everybody building this has a different experience, but with my helmet personally, I needed the magnets just right here, and that made the faceplates come together pretty much the same distance up and down. This is pretty much what I'm talking about. When I push these together, these magnets right here catch, and it's the same distance from each other from the top to the bottom. Because for example, if you place the one magnet you have right here on the chin, it's going to be more narrow at the bottom, and it's going to be more wide at the top. So you may be thinking, what is this helmet standing up on? What is this? And this, I think, is honestly super cool. So when you take the helmet off, you'll see this. So this is a great idea that the YouTuber Quest for Nostalgia came up with to make a stand for a helmet from only buying things from the dollar store. Literally all this is just a paper towel holder and this foam stress ball thing, and it really doesn't matter what color it is because you can just spray paint it black. That's what I'm gonna do. And all I did was just get a knife, slash a little hole through there, and just poke it through, and boom, you've got this great stand thing. And it works great. As you saw, it held up my helmet well, held it up a good distance from the ground, and without the context of this being a paper towel holder with the helmet on top, you'd probably never notice. But this was just a really good idea from Quest for Nostalgia, and I would highly recommend checking out his video and checking out his channel. So I think about the only other thing to show is how I connected this jaw, and it's really pretty simple. There's these little holder pieces that you can print, and there's holes in both sides of this jaw. So basically there's two parts that kind of stick out of the helmet where the jaw should be, and the jaw has two holes on either side where that spot goes in. So you place the jaw in the correct position, and then you print out these little pieces that just go on top, and they have like a little overhang, and it just basically secures the jaw in. There's a hole in there. You're supposed to actually screw them in, but my print just turned out way wrong, so I ended up just using a lot of hot glue. It works just the same, and it doesn't really matter because you're not going to be seeing the inside of this helmet. And as you can see, this is where the hair is just connected with a buckle and some straps, and I have it connected in 3 places, so that should balance it pretty well. So it's about time to get to that finishing sand and paint. See you on the other side. So now we start the long and arduous painting process. These are all of the paints that I used for this project. This glossy fire truck red from Rust-Oleum was a perfect match for Boss 3D's rendering of this file, and the paint has super good coverage. This Rust-Oleum matte black was perfect for the rendering as well. In the rendering you can see a clear difference in the glossiness of the red and the matte black, and I really wanted to have this show up in my build. Now we get to the metallics. This metallic, I think it's from Ace, is super pretty in my opinion, and it ended up looking great on the helmet, but it did take some work to get a good paint job with it. And finally, the Rust-Oleum matte metallic. Like the gloss red and the matte black, you can see a clear distinction in the metallics in this rendering, and I really wanted to make this show up in my paint job. But frankly, this paint was just absolutely awful to work with. I think I ended up getting more paint on me than on whatever I was painting. The last thing I did with these testing spoons was put a good clear coat over all of them, just to see what it would look like. Having all of these paints in a lineup was really useful in helping me see what the final product might look like. In hindsight, I might have chosen a different matte metallic, but honestly, I was just too lazy to go to the store and get another one. Side note, this isn't really important for the video, but I actually did all of the painting while it was snowing outside. Spray paints do get a bit iffy when it's so cold, so what I did was just soak them in warm water for a few minutes before using them, and that seemed to work just fine. So the first part I painted was the back plate. By the way, I did get a spray tint at this point, and it was absolutely wonderful. I'll link it in the description, but it's foldable so you can set it up wherever you like, and it works with a box fan to ventilate the fumes and a filter to catch the paint mist. Anyways, the first thing I did was put a coat of primer on this thing. Then I put on 2 coats of matte black about 10 minutes apart, but I would make sure to read the directions on the back of each spray paint because they're all a little bit different. After this, I put a Duplicolor matte clear coat over the black. Using a glossy clear coat would completely take away the point of using a matte spray paint, and I really wanted to clear coat as much of this helmet as I could. So this clear coat was awesome. It looked great on top of the black and it had really good coverage. I would highly recommend Duplicolor. The next piece I painted was the main dome, and I used the exact same paint with this as I did the backplate. The two are really meant to be one continuous piece, and the backplate just comes off if you want to get the helmet on. So I really wanted these to look as similar in color as possible. This one did have an extra step though. This model has 2 silver parts on each side that are almost like ears, and to achieve this effect I had to tape off the helmet so that only these parts were exposed. I just used regular painter's tape for this and covered the rest of the piece with plastic bags. This is going to become a common theme, and yes, it was very tedious. The silver paint is so pretty, but I had some real trouble with it throughout this project. I'm not sure if it was the freezing temperatures, a poor paint job, or a little bit of both, but I really had a time with it. Eventually I was able to get a relatively smooth paint job just by putting a ton of layers on. This part is definitely not my strong suit. The next piece to paint is that luxurious hair. Y'all know the drill, we're starting out with a good coat of primer. By the way, something I found extremely helpful while painting was setting up the parts on an old filament spool. It's at a good height to keep the parts off the ground, and it's easy to spin and maneuver so you can get all of those tricky spots. All I used with this was a generic white spray paint from Lowe's. I actually already had some of this to paint some pieces of my Star Boost Iron Man suit, and if you want to know more about that, there's a full playlist linked above. So this part was pretty easy, but of course it can't be that simple. If you look super closely at this model, you can just barely see that the back of the head isn't white like the rest of the hair, but metal. I could easily have just left it all white and no one would know the difference, but my perfectionism got the best of me, and I just decided to go for it. Taping this off was a real challenge, but I think anyone could do it that had the patience for it. And after I put a shower cap on this thing, it was ready for paint again. Well, I didn't realize that most of this was out of frame, but you get the idea. And now we get to the very last and most difficult part to paint, the faceplates. In total, this piece has 6 different colors, so we're going to go pretty in depth on this one. Most of the time, you want the first paint you lay down to be the one that covers most of the piece, and in this case, it would be that bright fire truck red. So before laying this paint down, I taped off every surface of the faceplate that wasn't going to be red. It's not as hard as it looks once you get the hang of it, it's just really tedious. There are 2 main ways I did this. One was ripping the tape into tiny sections and layering them to get the shape I wanted, and the other one was taking a one long strip and gradually creasing it to follow whatever line I was taping off. Once I was pretty happy with the finished product, I was able to get that awesome red paint on there. I don't know why, but I love this paint so much. It's just so satisfying. It has great coverage and it ended up being a perfect match for the helmet. So the next color to go is that matte black, and again I taped off everything but the spots that were going to be black. But this time I had the advantage of being able to put a plastic bag over it that just covered up the entire rest of the helmet. This meant that there was a lot less taping to do. The next to go is of course our Rust-Oleum metallic. Unlike the last part, which was pretty easy, this one took a bit more time. For this one I actually took all of the tape off and completely redid it. And like last time, the grocery bag worked wonders. As I said before, I had a bit of trouble with this paint throughout this project, but eventually I did turn out with a result I was pretty happy with, and that's all that matters. And the last color to spray paint will be the matte metallic that goes on the scroll in Cyberdemon's mouth. And for this one, I completely redid the tape one last time. After some serious struggles with this paint can, the spray painting for this project was finally done. So now we're on to hand painting, and I did hand paint these blue and green accents, but unfortunately I did lose the footage. But I do have some footage of doing some final touches on the faceplates. This black trim around the face would have been just one more thing to tape off during spray painting, so I just decided to do it by hand. I also went around with some white paint and just touched up some of the areas on the hair that accidentally got sprayed by that metallic spray paint. I did my best to tape it off, but it wasn't perfect. And finally, I fixed up the paint around these metallic ears. These were super hard to tape off because it's a complete circle, so I was bound to have some mess ups there. But after fixing it up with some black paint, you honestly can't even tell. So now it's time to put everything together. The back of the helmet went together super clean with those magnets, and I just used some hot glue to put those green resin prints on. Full disclosure, I was super cheap with the lights. All I did was get some cheap neon wires off of Amazon and just kind of stuffed them in there. I used a bit of hot glue just to keep it stable, but really that's all I did, and it ended up looking pretty good. So I will admit, I don't have the most experience in wiring, and I'm not the best at making it neat, so everything's going to be kind of jumbled up in there until I get a better system figured out. But for now, I attached these using some Velcro stickers. As I showed here, I just put both ends back to back and just find a good place to attach it inside of the helmet. It looks pretty rough in there, but it works for now. Well, there you have it. Ladies and gentlemen, after countless hours of printing, painting, wiring, everything, we have the Wash 3D Cyberdemon Genji mythical skin, the 3D printed helmet, equipped with lights and a moving faceplate, accurately painted to the best of my ability to Wash 3D's render. I genuinely hope that you all enjoyed this video, that it helped you in some way, whether you're trying to make this particular project or maybe this helped you with a particular aspect of another project. This project took an extremely long time to complete, so I so appreciate anyone who stayed till the end of the video. Your time spent on this video does not go unappreciated by me, and if you want to see more projects like this, feel free to subscribe.